if you have a function like fx and you have a function like gx, so we could do operations like addition. So fx plus gx, which can be written as f plus g. We can do product, which is fx multiplied by gx, which can be written as fx multiplied by gx. Now composite function, this composite operation is fgx, meaning you put gx inside of fx. That's what composite operation is all about. So when we talk about the composite operation, we're actually talking about putting one function into another function. So it's a new type of an operation. So in addition operation we add it up, in product operation we multiply. So we don't have to do either addition or product, but we have to do composite operation. So let's do an example of composite operation. So fx is 2x plus 5 and gx is 7x minus 1. So if they ask for fgx, so you have to put fgx. So gx is inside fx, so that means the f would be 2gx plus 5. That means instead of x we are writing gx. Whatever is here we write it here. So that means 2 instead of gx we can write 7x minus 1 plus 5. Now we can just go from this step to this step directly. We don't have to show this step. So this would be 7 to the 14x minus 2 plus 5, and that becomes 14x plus 3. Let's do another example of composite function. So fx equals to 5x square plus 1, gx equals to 2x plus 3. Now if we have to find f of gx, we can put gx inside of fx, so f of gx. So what we can do is we can write f is 5, instead of x we can write blank 5 blank squared, meaning gx squared plus 1, and in that blank we can just plug in gx, which is 2x plus 3. Now we can simplify this. In the algebra section, simple algebra section, where we have expressions, you will find out there is a rule called simplifying expressions. So we can simplify this. This is a plus b whole squared, so a plus b whole squared, we write it like this: a squared plus 2ab plus b squared. This would be, so a squared 2x whole squared is going to be 2x whole squared plus 2. A is 2x, b is 3, plus b squared means plus 3 squared, and there is plus 1. So this would be 5. 2x whole squared is 4x squared plus 2 to the 4, 4, 3 is a 12x plus 9 plus 1. So this would be 5 4 is a 20 x squared plus 5 12 is a 60 x plus 5 9 is a 45 plus 1. So in the simplest form, doing some algebra, it would be 20x squared plus 60x plus 46. Done. That's composite function. Now in composite function, they might even ask the question of g of fx or f of fx of g of gx. So let me show you an example of what would such an example be like. So if you have fx equals to 5x plus 1 and they ask for f of fx, that means the composite function is going to be f. Inside f you have fx, so it would be 5 blank plus 1 and fill in the blank with fx, which is 5x plus 1. So 5 into 5 is 25x plus 5 on the 5 plus 1. This would be 25x plus 6. So this is how it works. Now the final concept. So the final concept that we have to think about, let me scroll down here. Okay, this is good enough. The final concept that we have to talk about, it's inverse function. It's called inverse function. Now inverse function means something opposite. Now if I say something, I will do the job, the opposite of that is I will not do the job. So inverse means the opposite. So here remember, x becomes y and y becomes x. So in inverse function, x becomes y and y becomes x. That's what happens. So if you remember that x becomes y and y becomes x, then it can be done. So inverse function is, if fx is a function, then the inverse of this function is f. There's a little -1 here at the superscript. This portion is called superscript. This is script, this is subscript. So at the superscript we write f -1 x. That's the inverse function. So what we can do here, as an example, so find the inverse of fx equals to 2x minus 1. Now the first thing that you have to do is start with y, right? Convert the x to y. So let y equals to 2x minus 1. So the first step that you do for finding the inverse function is you just start with y. Now you convert the y to x. So we write x. So y plus 1 equals to 2x. Therefore y plus 1 by 2 equals to x. So we have x equals to y plus 1 by 2. So this is the function. Now we can write, therefore f inverse x equals to, now x equals to y plus 1 by 2. So instead of, if we write y plus 1 by 2, that cannot be the inverse function because we write f inverse x here, so it has to match. So it has to match. So this cannot be y. Instead of y, we change it again and we write x. So f inverse x is x plus 1 by 2. So that's what it is. Let's do another example, it will be even clearer. Find the inverse. Find the inverse of gx equals to 5x plus 3 by 2. So the first step is let y equals to gx 5x plus 3 divided by 2. So now we have to find x from here. So 2 into y is 2y, 5x plus 3. It has to be 2y minus 3 equals to 5x. Therefore x has to be 2y minus 3 divided by 5. So x equals to 2y minus 3 divided by 5. So all we have to do is write down the inverse function. So therefore g inverse of x is going to be, we cannot write 2y minus 3 by 5, we have to write 2x minus 3 by 5. That is the inverse function. So when you find the inverse function, remember we convert the x to y and the y to x. That's the concept of inverse function. So a recap of what we have been doing. So the first thing that we need to know is, what is a function? That's what we talked about. A function is any expression which for every individual input it has exactly one output, which might look obvious. Of course everything should have, but it's not obvious. For certain functions, for certain expressions, we might have more than one value. The next one, what is domain and range? Domain is the possible input value and range is the possible output value. Then how to evaluate a function, how to find the value of a function, where you have a domain and you get a range. Then how to find composite function, where you put one function into another. Then how to find inverse function. So that's how it works. So whenever we are talking about functions, we need to know about how to evaluate a function, how to find the composite function, and how to find the inverse function.